Welcome back to Chemistry, Chapter 8, Section 3, talking about classifying reactions. Today we are going to learn how to predict products of reactions. This isn't magic. We're not going to be Magic Genie with our casting spells. We're going to actually use what we know and what we've learned about the types of reactions to predict what might happen. So we're going to look at those 5 types that we learned last time. Those 5 types are combustion, synthesis, decomposition, single replacement, and double replacement. These are the 5 patterns that we learned last time. Combustion, C something plus oxygen. If you see that, you can predict what it's going to have. And each one of these has patterns that we learned last time. We'll go through those in a minute. So first off, combustion. Again, this is a carbon-containing material burning in air. It could be wood, it could be gasoline. In chemistry, we'll talk about things like butane or propane or things that are just one carbon. Products are always CO2 and H2O. We will not talk about incomplete combustion, which you may have heard about with CO gas. When a furnace burns with not enough oxygen, it could form carbon monoxide, which is poisonous and could kill you. But we're not going to deal with that. Another thing that is not combustion is when a metal reacts with air. So if copper reacts with air or with oxygen in the air to make copper oxide, that is not a combustion. An example of combustion would be something like this, C4H8 plus O2. Again, I see a carbon-containing material and I see oxygen. It's a combustion. It's going to burn to form CO2 plus H2O. No, this is not balanced. You would have to go through and balance this correctly after you figure out predicting the products. Decomposition reactions. I recognize this if there is only one reactant. So something has one thing that it starts with and says, usually has to add heat or add electricity or add a catalyst to make it start breaking up. If it doesn't do that, it generally is stable as that one compound. If there's only 2 elements in the one compound, it usually breaks up into its elements. Examples, if I have magnesium oxide, it breaks up into magnesium and oxygen. If there are 3 elements, it often will break down into 2 simpler compounds. They're still compounds. It doesn't generally break up into 3 elements. If I have A, B, and C, it does not usually go to A plus B plus C. This usually does not happen. It usually breaks up into a couple different cases. The first case we're going to look at is when you have a metal hydroxide. Remember, hydroxide is this OH. If I have this metal hydroxide and I heat it or electrolyze it or do something to make it break up, it always breaks up into the metal oxide and water. The other one is a carbonate. Remember, carbonate is the CO3. When it breaks down into carbon dioxide and again the metal oxide. So we're looking for things that have a metal plus and a polyatomic with oxygen in it. And those have special cases. These 2 cases you need to memorize. So you need to write these in your notebooks because otherwise you can't memorize them. You need to memorize those cases. Synthesis reactions. If we have only 2 elements or 2 very simple compounds, it's usually a synthesis reaction. Sometimes these are hard to tell from a synthesis versus a single replacement. After we go through more examples, maybe you'll see it more of the patterns we're looking for. If 2 elements combine, we have to make sure that they combine correctly. We're looking at the charges, balancing the charges. And again, that's going back to Chapter 5, memorizing your charges, knowing what they are. If it's a covalent compound, you may need to use your Lewis structures. But most of the time we're looking at ionic materials in this section. Examples, magnesium and chlorine. Chlorine is Cl2. goes to MgCl2. Sodium and chlorine goes to NaCl. Why did it not go to NaCl2? Because Na has a +1 charge and Cl has a -1 charge. So +1 and -1. I can't even write now. +1 and -1 equals 0. Magnesium had a +2 charge with chlorine's -1. So if I do a +2 and I have to do 2 of the -1 charges to equal 0. Again, use those subscripts to balance the charges. Again, we have the same issue when we have metal oxides with water or carbon dioxide. These are actually the opposite of the decomposition reactions I just told you to memorize from the previous page. Example, H2O and magnesium oxide forms magnesium hydroxide. Again, your metal oxide with your water forms your metal hydroxide. Opposite of the one I just told you to memorize. So you will have to memorize these and know these backwards and forwards. It could happen either way, depending on the conditions of the experiment. If I have a carbon dioxide, which is right here, with my metal oxide, I'm going to form a carbonate. Carbonate is anything with CO3 in it. Again, it's the opposite of what happens when this goes the other direction. It breaks up into the metal oxide and the carbon dioxide. Okay, single replacement reaction or single displacement. Sometimes I put two things together. I don't know if that reaction is going to happen or not. And sometimes it happens and sometimes it doesn't. We're going to use something called the activity series or metal activity series. This is just a short sampling of one. There's actually, you can look at activity series with more compounds. There's more in appendix in your book. So if you come to a homework problem that asks you for a single displacement and you don't have it in this table, look in the back of the book. It might be there. That's a longer table. But elements are arranged in order of activity. And this activity helps us to predict if the reaction is going to happen. These are more reactive as you go to the top and less reactive as you go towards the bottom. So I'm looking at, if I put two things together, whatever is on top is most active. That's the one that is likely going to get the ion or the electrons for itself. Examples of this. Magnesium is placed in nickel sulfate solution. Will it react? So we need to look at the activity series. Which is higher? The higher metal gets the anion. The anion is the special prize. So the bigger bully gets the prize. So we need to find out which one is the bully, nickel or magnesium. So I go back to this table and I find magnesium right here and I find nickel right here, which tells me that magnesium is the big bully and nickel is the little one. Will it react? Yes. Magnesium gets the sulfur, or the sulfate ion will form. And nickel is left by itself. Next one, magnesium is placed with calcium sulfate. Will it react? Now, the question is calcium a bigger bully or a smaller bully? And we go back to our chart and we find calcium is up here above magnesium. So calcium is the giant in this case. Will it react? No. Calcium is more active. So no reaction happens. Last thing I want you to pay attention to, there are some elements which always form a diatomic molecule. Diatomic meaning two atoms. So if I found nitrogen as an example, in nature, naturally, it would not just be N floating around, it would be N2 always. Same with oxygen. Oxygen is always O2 if it's not combined with another element. So the following 7, and again, look at where they're in your periodic table. Your halogens, right here, your halogens, and then oxygen, hydrogen, and nitrogen are all close to the same electronegativity. So that's our group we need to make sure you memorize. If you have a single replacement happening, and it forms chlorine, or it forms hydrogen, or forms oxygen, make sure that you include the 2 so that you're balancing your equation correctly. Don't just write it plus H. You have to write plus H2. This one would be incorrect. So the last type, this is in your textbook. You can't really read it on here. Get rid of my screen. We'll do some practice problems in class. We'll go through this chart to talk about how to do it. The last section of the double displacement deals with solubility. That's a whole separate section in itself. So today we're going to deal with these 4 reactions that have to predict combustion. You're looking for CO2 and water being formed. Displacement, if you have one thing, element displacing another one, you're looking for which one's high in activity series. Synthesis, when you have 2 small things forming one. And you have decomposition, when you have start with one thing and you form 2 smaller ones. Again, there were 3 things I told you to memorize. One is to memorize those polyatomics. The other thing you need to memorize is these. And it's just the opposite of the decomposition. So you can remember those either way. That's if you count that as one thing or 2 things to memorize. You have to know them either way. So make sure you have those written down. Go through the video again if you need to. And be ready to practice doing some of these in class.